Yes, dear students. Now I'm going to discuss one more lecture, some questions from electricity chapter. See, the question one is: so, what are the advantages of connecting electrical devices in parallel with the battery instead of connecting in series? It's a very interesting question. So, question is again I will repeat: what are the advantages of connecting electrical devices in parallel with the battery instead of connecting in series? See, what are the advantages when the electrical devices are connected in series? I mean, connected in parallel instead of series. See, for example, when a number of electrical devices are connected in parallel. So when we connect in parallel, we know very well what are the importance of electrical devices are connected in parallel. So then each device gets the same potential difference provided by the battery. Already I told. So whenever the resistors are connected in parallel, the potential difference provided by the battery is the same for all electrical devices, but current is only distributed for each resistor. That I am discussing here. So when a number of electrical devices are connected in parallel, each device gets the same potential difference provided by the battery, and it keeps on working even if other devices fails. Right or not? So for that only in households, in our homes, we will connect that we will give the circuit is connected in parallel. Why? Because for any one electrical device, like for example, when we are in home, for example, 5 volts and one fan, right, and a different electrical device like a fridge, like a cooler, everything will be there. For example, so due to some problem, due to some voltage fluctuations, one bulb will be fail. So if we connect in series, if one will be bulb will be fail, means all electrical devices remaining, all remaining fan, fridges, everything will be fail. So but we will connect when we will connect in parallel. Of course, one bulb will be fail due to the some voltage fluctuations, but remaining bulbs and remaining electrical devices safely is there. Why? Because we are connected in homes, the circuit should be like parallel. So why? Because for each electrical devices, the potential difference is provided by the battery, right or not? So for that only, and the current is distributed for each electrical devices, right or not? So for that only, in homes we are connected parallel circuit, we are giving in parallel circuit. So this is not so in case the devices are connected in series. That only I told know. Because when one device fails, the circuit is broken and all devices stop working when we are connected in series. So for that in a households we are connected in parallel circuits. The second one, the parallel circuit is helpful when each device has different resistance and requires a different current for its operation, as in the circuit, as in this case. So for that I told already, in parallel circuit, each device distributed different current. For that I is for example, three resistance are there, different resistance. It have different it will be get different currents, like equal to I1 plus I2 plus I3. So for that in this case, that only the current is divides itself through different devices. This is not so in series circuit. It is, but in series, potential difference is divided, but current is same. So for each device, current is same only. So for that only, if one device fails in series, other device also fails. Series circuit where same current flows through all the devices in series, irrespective of their resistance. This is about so what are the advantages of connecting electrical device in parallel instead of in series. And see second question, how what two connecting wires, it is important model of the same material and of equal lengths and equal diameters are first connected in series and then in parallel in an electrical circuit. The ratio of heat or power produced in series and parallel combination would be. Just listen carefully the question itself you can understand easily, you can do solution. Two conducting wires of the same, two, it is not one, two conducting wires of the same material and of equal lengths and equal diameters are first connected in series and then in parallel in an electrical circuit. Then the ratio of heat or power produced in series and parallel combination would be. See, the solution is, since both the wires are made of the same material, they are mentioned two connecting wires of lengths and diameters, then these have the same resistance, let it be R. For example, I given the resistance is R. Why? Because each since the both of the wires are made with the same material, of course equal lengths, of course equal diameters. So when for example two materials are connected in series, it means two wires or two materials are connected in series, then equivalent resistance is one resistance have R, they given each material have same length and same diameter. For that only I given R. Then for that only R is equal to R plus R, it is 2R. When connected in series. When connected in parallel, 1 by Rp equal to 1 by R plus 1 by R, it is a 2 by R, then Rp equal to R by 2. Here Rp is nothing but resistors are in parallel, Rs is nothing but resistors are in series. Now we can use power or heat produced. I can use a formula electrical power P equal to V square by R. So power or heat produced in series Ps equal to V square by Rs, and power or heat produced in parallel equal to V square by Rp. See, now we have to calculate what is the ratio of power produced in series and parallel combination. Then it is a Ps by Pp equal to V square by Rs by V square by Rp. Then this it will be reversed. This fraction will be reversed. Then V square by Rs into Rp by V square. This V square cancel each other. Then it is Rp by Rs. So already we calculate Rp is nothing but resistance or parallel is R by 2, and resistance or series is nothing but 2R. Then Ps by Pp equal to R by 2 and 2R. So 2 into 2 4, these are cancel each other. So further Ps by Pp equal to 1 by 4. The ratio of resistors are in series, the ratio to the resistors are connecting parallel is equal to the 1 by 4.